Welcome to this tutorial dedicated to version control systems for TIA Portal. We will see how to transform your PLC projects into real Git repositories, with precise and professional versioning. On the agenda, creating the GitHub repository, configuring access, first commits with FC and FB blocks, synchronization with GitHub, and finally, the ultimate demonstration, deleting the project and rebuilding it entirely from the remote repository. We will see 1. Creating the repository on GitHub. 2. Generating the access token. 3. VCS configuration and initialization. 4. First commit and push to GitHub. 5. Progressive addition of blocks, FC, FB plus DB, tags, UDT and DB with commits. 6. Visualizing the diff and history. 7. Deleting the project and restoring from GitHub. The first step takes place on GitHub. We are going to create an empty repository for our project. Follow the instructions displayed in your terminal. For TIA Connect to communicate with your GitHub account, you need to generate a personal access token. It is a security key that replaces your password. Warning: copy the key carefully, it will only be displayed once. We are now configuring the developer identity and GitHub access in TIA Connect. The token is stored in an encrypted format on your machine using DPAPI, the secrets of the Windows encryption engine. It will never be visible in plain text in the project files. This is where the magic happens. The VCS init command creates a local Git repository next to your TIA portal project. It will export all your blocks, tags, types, and hardware in standardized XML text format. This text format is what enables versioning, unlike the .ap20 binary file that TIA portal normally uses. We link our local repository to the remote GitHub repository, we create the first commit with the initial state of the project, and we send everything to GitHub. Let's check on GitHub that everything has arrived. We create our first function, a utility FC with conversion functions. After compilation, we commit and push to GitHub. Each commit captures a precise moment of our project. Now, a more complete functional block, a motor control FB with its instance DB. The FB contains the logic, and the DB stores the instance data. This pattern is fundamental in PLC programming. We commit and push. A second FB, this time for controlling a valve. Notice the workflow: we create, we compile, we commit, we push. This is the discipline of the modern PLC developer. A PLC project is not just about blocks. There are also variables, tags. We create a tag table for motor inputs: start, stop, fault, run, feedback. As with the blocks, we commit and push. The VCS also exports tag tables in XML. User data types, UDTs, are also included. We create a structure for MotorData. This type can be reused in all our functional blocks. One more commit in our history. A global DB to centralize the configuration parameters of the installation. Maximum number of motors, cycle time, plant name. This type of block is often the first to be modified during commissioning. All the more reason to version it. A diagnostic function, essential in any industrial project. It collects equipment faults and generates a summary alarm word. New block, new commit. The history grows with each step. Here is the true power of versioning. We modify our motor FB to add an automatic stop. With VCS status, we see exactly which files have changed. And with VCS diff, we see line by line what has been added or modified in the XML. No more guessing, every modification is precisely tracked. Let's now look at the complete history of our project. Each commit tells a stage of development: the initial project, the utility FC, the motor FB, the valve FB, the tags, the data type, the configuration DB, the diagnostic function, and the modification with the automatic stop. 9 commits, 9 precise and timestamped milestones. It's a complete logbook of all the work performed. And now, the ultimate demonstration. We are going to close and completely delete our TIA portal project. Yes, you heard right. The .ap20 file and the entire project folder will disappear. In a real scenario, this could be a disk crash, human error, or a workstation that dies. The question is, can we recover everything? We recreate a blank TIA portal project with the same name and the same CPU. For now, it's an empty shell, no blocks, no tags, nothing. We initialize the VCS on our blank project, we connect it to the same GitHub repository, and we pull the entire history. Look, all our commits are there. The complete development history survived the destruction of the project. And now, element by element, we restore everything from the Git repository. The FCs, the FBs with their instance DBs, the configuration DB, the data type, the tag table. We compile and everything passes. Our project is resurrected, identical to what it was before deletion. 8 blocks, 1 tag table, 1 UDT, everything is back. And not just the last state, we could restore any previous version of any element. Let's recap what we have just demonstrated. We created a Git repository for a TIA portal project, developed progressively with commits at each stage, synchronized with GitHub, visualized differences line by line, and above all, we proved that a destroyed project can be fully restored from the remote repository. This is the security and traceability that every industrial project deserves. Thank you for following this tutorial. In the next episode, we will go even further. We will see how to set up test-driven development for automation, with the test harness integrated into TIA Connect. Writing tests before code, executing them automatically on a simulated PLC, and validating that your logic works even before commissioning. See you soon on TIA Connect.